Whatever, Danny. Oh, yeah, that's kind of a lot of questions. I guess that'll do the job. Alrighty then. So, oh my goodness, these are all things. Did you notice like the practice test I gave you? This stuff from the regular homework. This is A/B, people. There's no tricks. You just gotta do what you're taught. You don't have to like even extend your thinking even a little bit. But whatever. Okay, we start with number 2. That means we could do number 1. Thank goodness. Number 2. Right? Okay, so you have it. Okay. This is one of the problems. In fact, every one of these problems is on the test. It's just like different. Okay, wait. So what do you do when you see an absolute value? A, pretend it's not there. B, skip to the next problem. Or C, write a piecewise function. Yeah, I think we know that already, right? So here's the absolute value. There's only 2 possibilities. You're either going to leave it alone or negate it. That's how absolute value works. So if the inside is positive, you leave it alone. You use this one. So you get x minus 2 over x minus 2. Hey, that simplifies to, rhymes with 1. 1. And then when the inside is negative, you're going to negate it. So you're going to use this one. So you get negative x minus 2 all over x minus 2. Can I simplify that one? No. Okay, so that's good. Now we got to graph it. So I'm guessing each one of these individual problems are going to be like 5 points each. But if I want to give you some free points, I'll just make them 4 points each. That way you have more free points. Okay, it doesn't seem like you wanted 5. Okay, let's graph the harder one first. Let's graph this one because it's a rational function. Go through the 4 steps you were taught. X-intercept. What makes the top 0? Negative 2. Y-intercept. Substitute 0 for x. Really? Look, you just gotta do this. 1. Vertical asymptotic. That's when the denominator is 0. And horizontal, if the degree of the top and the bottom are the same, you look at the coefficients. Negative 1. Y equal negative 1. So that means the graph looks like this. And how come they go opposite way? Because you got an odd power in the denominator. Odd power in the denominator goes opposite way. Even goes the same way. Anyway, if you did it up there, it would cross the x-axis and no can, right? So it has to be done there. But we're not going to graph the whole thing. We're only graphing it when x is less than 0. That means to the left of the y-axis. So that means everything to the right of the y-axis, we're just erasing. So there, open circle. So that's the graph of this one. What about this one? Come on, y equal 1. That's a horizontal line. And then including the 0, so, wow! Box that, that's the answer. No, that would be a minus 1. How come? Yeah, there should be a removable discontinuity at 2 there. Why? Yeah, because the denominator cannot be 0. X cannot equal 2, right? So even though they cancel out, remember, when you cancel out things, there's going to be a removable discontinuity there. There we go. Okay, so that would be 4 and 4. This is like a 2-part problem, eh? 4 and 4. What did we get on this? Hopefully not a fatal error. 0 out of 8. That would be kind of painful already. 3A, 3C. We don't have to do 3B. What the heck? Let's just do them all. What the heck? To get it on the video. 3A. It's a piecewise function. You know, I'm not going to write it again because you guys have it. Let's just start graphing this thing. Now, tomorrow, you know, in calculus, everything is done freehand. Don't bring rulers or things like that. Just draw it freehand. That's how it works. Okay, so which piece do you want to start with? Sine. X is less than negative 1. You have sine of pi x. Now, I don't know what's, you can plot points, or here, you can graph sine. Here, this is what sine looks like. Usually that's 0. This would be negative pi, negative 2 pi, pi, and 2 pi, correct? But what does the pi x do to the graph? It multiplies the x coordinates by 1 over pi. So like if you multiply this by 1 over pi, you can get 2. That becomes 1. This becomes negative 1, and that becomes negative 2. So if you were to draw it, it would look like this. Okay, here's 1 and negative 1. It would look like this. Wait, negative 1 is here. So it would look like this. And so forth, right? That's kind of ugly. But we're only graphing it when x is less than negative 1. So here's negative 1. And so that's the graph right there. Did we get that? Okay, and then the second piece. What is this graph again? I told you guys before, but then some of you probably forgot. What is that? Semicircle of radius 1. You need to know this. This is super important in calculus. Mr. Park, everything's important. That's right. And then if you put a minus in front of it, it reflects it over the x-axis. So instead of the semicircle being up there, it's going to be down here. Does it include negative 1 and 1? Or yes, it does. So then it gets filled in. And then the last piece is natural log x. Now natural log x looks like this. Here is the point 1, 0, and then it looks like that, right? But we're only going to graph it when x is greater than 1, so just like that part there. So open circle, but then it was filled in already, and now, so did we get something like that? Yeah, then good. Minus 0. That's what we want. You want minus 0. So every test you take, you're probably going to get like 20 or 30 free points, depending. So if you completely bomb, no worries, you got 20. No, you still got to worry, man. Why? No, because you get 20. That's disastrous. But 0 is even more disastrous. Okay, so draw the base graph. Okay, so the range, remember the range. This one is 0 to pi, right? Because it has an odd number of c's. So the graph looks like this. Right? And then what does the absolute value on the x do? In fact, we just did one for the quiz, right? Erase everything to the left of the y-axis, keep and reflect the remaining portion about the y. Anyway, if you have trouble graphing, you know, what's the last resort if you don't know what to do? Plot points. Plot points. But some of these graphs are, I think, too hard for you to plot points. Like here, plug in 0. See, right away you kind of plug in 0. See, so how are we going to plot points? How are you going to plug in 1 or anything like that? Woo! And then, okay, are we doing C? You get your sweep in. Y equal absolute value equal. Okay, always start with, this looks like the quiz one. Start with the base graph, e to the x, here's the point 0, 1, and then no. What does that do to the graph? It reflects it over the y-axis, so it goes like this. What does that do? Shift it, that's the same as the quiz, wasn't it? So this asymptote goes down 1, so it's over here, and so now the graph looks like this. Oh, but this one has one extra thing. Absolute value on the whole thing means everything below gets reflected above. So this part is going to get reflected above, which means this asymptote also gets reflected up there. So it's going to look like that. And then if it's above the x-axis, you just leave it. So it kind of looks like that. And again, when you draw it as, you need to, if a graph has an asymptote, you need to draw it in. Well, I guess you don't have to. Everything's optional in this class. You're just going to get the minus points. All right, we're moving on. 3, 4, 5. Oh, there's a gap there. Okay, 4. 4. Oh, here's the difference quotient problem, just like on the quiz. So, the only thing that's going to change is this. You are going to get this difference quotient problem because, again, all of calculus is based on this thing. So you have to compute this difference quotient, f of x plus h minus f of x all over h. In fact, that's the start of chapter 3 right there. Okay, So, let's go piece by piece, start with this. F of x plus h means substitute x plus h for x right there. So you're going to get 1 over x plus h squared. Minus f of x is the given function. And then you divide the whole critter by h. Alright, you write that on your paper, you don't want to give you 1 point. You want the other 3 points, so you got to simplify this. Now how the heck do I simplify this? Well, when you see fractions, how do you subtract fractions? What do you do? Least common denominator, which is x squared times x plus h squared. And then what goes on the top? X squared minus x plus h squared. See, the hard part is always the algebra. And then when you divide by h, that's like multiplying by the reciprocal, right? When you divide by something, that's like multiplying by the reciprocal. Okay, now what? Multiply out the top. So you got x squared minus, and you got to expand this and distribute that minus sign now. X squared minus 2xh minus h squared. Algebra mistakes typically would be minus 2 for each one. Arithmetic, minus 1, typically. Okay, and then, hey, the x squareds cancel out. Is there a way I can do any canceling with the top and the bottom?
Factor.
Yeah, factor out the h. So if I factor out the h on the top, you're going to get h times negative 2x minus h all over x squared, x plus h squared, h. h's cancel out. Final answer, survey says. Cha-ching! See, after you do the difference quotient thing, after that, it's just all algebra. That's all it is, it's algebra. 5. Oh, this is a good one. Okay, so we have f of x is equal to 2x plus 1 over, I can't even read this thing, 3x minus 2. Now it says, find g of x so that g of f of x is equal to x. Now, you guys know this means the same thing as g of f of x, right?
Yes.
Okay. So, what is the g function so that when you plug it into this, here and here, the answer will come out to x? Well, let me ask you this. If you have two functions, and you plug one into the other, it doesn't matter which way, and the answer comes out to x, what does that mean about these two functions?
Inverses.
They're inverses of each other. So basically, I'm just asking you to find the inverse of that. Well, Mr. Park, how come you didn't just say find f inverse? Because I want to see if you know something. This is an important property in calculus, that's why. So yes, all we have to do is find the inverse of that. That's the problem. So how do you find inverse? This is like y now. Switch the x's and y's. Now can you do it? I bet now you can do it. Yeah, that's all we have to do. I thought it was more, but no. So how do you solve for y now? Cross multiply. It's just like that problem on the quiz we just did right there. Put all the y's on one side. So here, two terms of y. Put all the y's on one side. I don't care which side. Doesn't matter. Put everything else on the other. Factor out the y. Divide 2x plus 1 all over 3x minus 2. Box that, that's the answer. See, it's just algebra. Number. Hey, we don't have to do 6. That's because we can do synthetic division. Very good. 7. Oh, we don't like an trig, eh? F of x is equal to sine 2. Okay, there's one. In fact, I think I made the test this morning. This is the last problem on the test. It's an inequality with trig functions. When is this function less than 0? You know, there's going to come a point somewhere in the end of the first quarter where you're just going to make number lines on every single problem. You got to be good at it. And that's what you're going to do. Make a number line to this. Now, in order to make a number line, you got to make one side 0 and you have to factor the other side. So what? What do I do? How do I factor the left side? What do I do with this critter? you have to use the identity. There's only one for sine 2x. 2 sine x cosine x. Factor out the cosine x. And what a surprise! These are all numbers we're supposed to know for trigonometry, right? So, make your number line. What makes this thing 0? Cosine of what angle is 0? Pi over 2, 3 pi over 2. What makes this factor 0 when sine x is negative half? 7 pi over 6, 11 pi over 6. And then none of these are going to be part of the solution, so we put open circle. Now test. What's a good number to plug in here? Rhymes with hero.
0.
0. So cosine of 0 is 1. That's positive. Sine of 0 is 0. 0 plus 1 is positive. Positive times positive is positive, and then just alternate them, yeah? No, there's no pattern with trig functions or any, like e to the x, natural log x. There's no pattern. Only polynomials have a pattern. Okay, so at least you can like do this. Like if you plug in 0 and 2 pi, shouldn't you get the same result? Because 0 and 2 pi is the same place on the unit circle, right? That'll save a little bit of time. So it's probably going to be like 1 point for each region. That's probably how it's going to break down. Yeah? So what's a good number to plug in between pi over 2 and 7 pi over 6? Pi, okay? Cosine of pi is negative 1, so that's negative. Sine of pi is 0. 0 plus 1 is positive. Negative times positive? Negative. Okay, good. What's a good number to pick between here? Maybe we should draw it. What's a good number to pick between 7 pi over 6 and 3 pi over 2? 5 pi over 4. 5 pi over 4. Cosine of 5 pi over 4 is negative root 2 over 2, so that's negative. Sine of 5 pi over 4 is negative root 2 over 2 times 2. Negative root 2 plus 1. Negative root 2 plus 1. Is that negative or positive? That's negative. So negative times negative is a positive. Mr. Park, it's alternating. And then what's a good number to pick between 3 pi over 2 and 11 pi over 6? Somewhere over here. 7 pi over 4, right? Cosine of 7 pi over 4 is root 2 over 2. That's positive. Sine of 7 pi over 4 is negative root 2 over 2 times 2 plus 1. So positive times negative is, Mr. Park, all 3 of the problems we had for homework alternated. Well, you know what I'm saving for tomorrow, right? The one that doesn't alternate. But now since I told you that, it's gonna alternate. But now since I told you that, I'm gonna change it back. Anyway, which ones do I shade in? The minus signs or the plus signs?
Minus.
Yeah, because less than 0 until mama, mama. There you go, and then you can write your answer from there. Yeah. All right. Pretty much in AB, every single one of my tests, every year, it's the same thing. There's no tricks. You just got to be able to do it. Okay, so that's number 7. Is number 8 up there? Yes, it is. Solve for x. Okay, so you have to prove to me that you can use your properties of logarithms. Natural log of x minus 1 minus natural log of x minus 2 is equal to negative 1. Okay, now look at this. Can I use a property of logarithms to combine those together? You bet you sweet baby I can. Natural log of x minus 1 over x minus 2. How come? Because remember, natural log m minus natural log n is equal to natural log m over n. That property? Now, the reason why you want to write it as one logarithm, because how can I get rid of this logarithm? You e both sides. E to the natural log gorilla is gorilla. E to the negative 1, of course, is just 1 over e, and then now you just reduced it to an algebra 1 problem. Cross multiply. Put all the x's on one side. See here, the two terms. Put all the x's on one side, put everything else on the other. Factor out the x. Hey, we do this kind of planning, mister. So, and then divide. E minus 2 over e minus 1 cancel out the e's, cancel out the negative sign, so you just get 2 over 1, which is 2. Well, I tell you, if you did that, all the good that you did just got wiped out. W minus 4. This is your answer. You can't cancel out the e's and the negative signs. What are you guys talking about? Oh, we don't have to do number 9, that's good. Hey, 5, 8, that was just like the quiz problem. Number 10. Oh, okay, you gotta show me that you can do things to graphs. Okay, so you have this graph. Now to me it doesn't matter if you write f of x or y because it's the same thing, right? Okay, you start with the graph. It says, I'll write the equation of the graph obtained when this is first reflected about the x-axis. How do you reflect the graph over the x-axis? What do you have to do? It's on the notes, people. Negative f of x, you multiply the entire thing by -1. So if I multiply this entire thing by -1, now where do you want it? You want to put the negative in the middle, or you want to put it on the top or the bottom? What do you want to do? Yeah, I heard somebody say put it on the top. It does look, that's the same thing as that, right? It doesn't matter where it is. Let's put it on the top. Next, it says, stretch it vertically by a factor of 2. How do you stretch a graph vertically by a factor of 2? That's this. You simply multiply the whole function by 2. So now you're going to get this. Here. I'll just do it step by step. Just multiply the whole bloody thing by 2 like that. And then now simplify. And then finally, look at the right problem, number 10. Translate it 1 unit to the left. How do you make a graph go 1 unit to the left? F of x plus 1. Come on, you guys learned this from Algebra 1, right? Okay, so all you have to do now is substitute x plus 1 for x. So y equal -2 x. Wherever you see x, just plug in x plus 1, and that's going to shift the graph 1 to the left. And then the final step is to simplify. 2x minus 2 all over x plus 4. Can I do any canceling? And lose all the good that you did? No, just leave it. Number 10, number 11, A and B. Well, isn't that the whole thing? Number 11, okay, this is the word problem. Now, I'm going to tell you right now, on the word problem tomorrow, if you miss part A, you automatically miss part B or okay? So, if you miss part A, that's like -8, you know. So, make sure you get part A. I'm not even going to give you a really hard one too. It'll be like one you've seen before. So, just like this one, we did this one before. A cylinder is inscribed in a sphere of radius 6. X represents the distance from the center of the sphere to the base of the cylinder. Okay, that was a homework problem, I remember. Write the volume as a function of x. Okay, now, you got to remember your formulas now. What's the formula for volume of a cylinder? Pi times the radius squared times the height. Now look at this picture. What is the height of the cylinder? 2x. Okay, should I give you 1 point for that?
Yes.
I don't think so. Okay, but what about the radius? This radius right here. How do I write the radius of the cylinder? Well, the only other information that was given is that the radius of the sphere is 6. How did we draw this in before to help us solve the problem? Yeah, right there, 6. It makes a right triangle, so you can use the Pythagorean theorem. Now, are we at the stage? Remember when we first did this a couple weeks ago? You had to do the box method, but now you just look at it and go, hey, root 36 minus x squared. Or are we still using the box method? Why am I even waiting for a response? I'm the stupid one. Square root of 36 minus x squared, and then we simplify it, so you get 2 pi x times 36 minus x squared. There! I got 4 points! Now, part B. For what values of x is the volume of the cylinder equal to 128 pi? So, I want to know when is this equal to 128 pi? Now, how the heck am I going to solve this equation? What the heck? Without a calculator. There's no calculator tomorrow, huh? What's the first thing you should do? Divide both sides by 2 pi. So divide by 2 pi. If you divide this by 2 pi, that's 64. Hey, well look at what I got. 36x minus x cubed is equal to 64. What a surprise. It's a cubic function. There you go. And how do you solve a cubic equation? Synthetic division. So 1, don't forget to put the 0 because there's no x squared term. And since we're AB, either 1 or 2 is going to work. And what? Okay. Can you see that 1 is not going to work? Because if you plug in 1 for x, is 1 minus 36 plus 64 equal to 0? Really? No. So it has to be 2. Now, if 1 or 2 doesn't work tomorrow, go back and check something because 1 or 2 has to work. That's the AB rule. 2. 1, 2, 2, 4, negative 32, negative 64, 0. See, I told you? The AB rule works. So, x minus 2 now. Minus 2, not plus 2, because that would be a minus 2 error if it were plus 2. And then the other factor comes from that. X squared plus 2x minus 32. Is that factorable? No, so you gotta use quadratic formula. So what are your 3 answers? 2, and this one you gotta use quadratic formula, so let me just do it. Negative 1 plus or minus root 33, is that right? Of course, I'm the teacher. Box that, oh, that's the answer. Minus 1. How come I get minus 1? Because x represents a length right here. See, x is a length. In fact, if you look at this picture, doesn't x have to be between 0 and 6? Otherwise, the problem doesn't even make sense. So any answer that is not between 0 and 6, you got to cross out. In this case, Mr. Parker, take the minus 1. 99 is a darn good score. You're right. 99 is a darn good score. Right, so there's 1 word problem tomorrow, so it's 8 points now. You know why you're going to get a minus 8 if you don't get part A? Because if you don't get part A, when you set the thing equal to that thing there, you're going to get an unsolvable equation. Oh, I don't know, you might get lucky, maybe it is solvable. Because you're going to just be hunting for synthetic division answers and you're not going to get any. Number 12. Hey, we're almost at the end. Oh, the half-life problem. Okay, the half-life, y equal y naught. Okay, now it says the half-life. If it's half-life, what number do I put in the parentheses? What if it said the population increases by whatever, 50%? Then what would you put in there? 1.5. What if the population decreases 25%? Then what would you put in there? 0.75, right? This is like SAT problem, right? Every 7 hours. So what do I write? T over 7. So you have to start with this. How many hours will it take for 90% of the sample to decay? Well, if you start with something, if you start with y naught, now notice that I didn't tell you what y naught is in this problem. You start with y naught, this is your initial amount. If 90% of it decays, how much is left?
0.1.
Yeah, 10% is left. So 10% of y naught is 0.1 y naught, right? Where do I plug that in? You plug it in for y. So 0.1 y naught is equal to y naught 1/2 t over 7. And can you see why it doesn't matter what the initial population is? Because it cancels out. It doesn't matter what it is. So all you have to do now is solve for t. That's the time it'll, yes. Yeah. So how do I solve for t? It's in the exponent. What do you think I'm going to do? Come on, we did this how many times on the course? Natural log both sides. natural log of 0.1 is equal to the natural log of 1/2 to the t over 7. Now, why do I natural log both sides? Because you can put the power in the front. Once that power comes to the front, it's an algebra 1 equation. So all you have to do now, multiply both sides by 7, and then divide by natural log 1/2. Cancel out the ln, so you get 7 times 0.1 all over 1/2. Cancel out the fraction sign, so you get 7 over 0.1 all over 2. Cancel this thing with that thing. So all you have is 7 parentheses, left parentheses 0.1 all over underline 2. Oh, that's wrong. You know why? We already canceled the fraction, so it doesn't have this. There, that's the answer. 7 left. No! If you do something like this, you just undid all the good that you did there. This is the answer. Now, you can leave it like that, or if you want to impress me tomorrow, you know what you can do? Like, I don't know how I wrote the answer on the bottom, but this is how I think I wrote it. I think I wrote 7 natural log 10 over natural log 2. Yes or no? Yeah. Now, if you want to impress me tomorrow, then that's what you do. Mr. Park, how do you do that? Well, isn't 0.1 the same thing as 1/10? Yeah. And isn't 1/10 the same thing as 10 to the negative 1 power? Isn't 1/2 the same thing as 2 to the negative 1 power? And when you have a logarithm, what can you do with the power?
Move to the front.
Put it in front, put it in the front. A negative divided by a negative is a positive. And there you go. Because the reason why I'm training you, because on the AP exam, you're gonna get this answer, which is correct, but that's not how the choices are. You gotta be able to simplify it. I'm telling you, that's how it is on the AP exam. That's how they test to see if you know your properties of logarithms.
Would we get bonus points if we did it like that?
No. You just get minus points. See, that's not above and beyond. Like if you went above and beyond, then I'll give you bonus points. And then finally, 13. 13C and D. Okay. We're almost done. Cosine of something minus, no, it's plus something. Now these inverse thingies here, are these angles that we just know off the top of our head? Like pi over 6 or pi over 3 or something? No, so you should probably call this alpha and beta, right? And then draw the picture. So how do you draw the angle for sine inverse 4/5? Sine of what angle is 4/5? Well, opposite over hypotenuse. Well, that angle right there. And then this means the tangent of what angle is 5/12? Well, opposite over adjacent is tangent, and then use the Pythagorean theorem. So this is that angle, and this is that angle. Okay, now, how do I compute the cosine of this angle plus that angle? Do I just distribute the cosine and just undo all the good that you just did? No! In fact, that would not just be a fatal error. I'm going to make that a double fatal error. Minus 8 instead of 4. It's an error so bad you can't recover from it. In fact, I changed my mind. Triple fatal error. No, I don't. You have to use an identity. What is the cosine of gorilla plus banana? Cosine gorilla, cosine banana, minus sine alpha, sine banana. And then now you look at the triangles you drew. What is the cosine of this angle here? Adjacent over hypotenuse. What's the cosine of this angle? Adjacent over hypotenuse. What's the sine of this angle? Opposite over hypotenuse. And what's the sine of this angle? Opposite over hypotenuse. Now, once you write this answer here, the most you can lose is 1 point for the simplifying. Simplifying is 1 point at the most. So what do we got here? 36 over 65 minus 20 over 65. So that's equal to 16 over 65. Cancel out the 6's 1/5. I'm going to impress Mr. Park. That's 0.2. No, you just impressed me with this part right there. You can't cancel out the 6's. This is the answer. And then finally, the last problem, D. Where's D? Cosine of double angle. Arc, tan, 4 kids. Now, is this an angle that I know? No, that's not an angle, but I can draw the picture, right? You want to call that theta? Arctan is opposite over adjacent, and then what? 3, 4, 5. Don't be ridiculous. That's root 41, right? 25 plus 16. So what is the cosine of 2 times this angle? Can I just go cosine and then times it by 2? No. No. You have to use identities. What is the cosine of 2 theta? Think of this as theta. You got 3 identities. This one, it doesn't matter which one you use. Cosine squared theta minus sine squared theta. This is my favorite. You guys probably have your own favorite. Now you look at the picture. Cosine theta is adjacent over hypotenuse, so it's squared. Sine theta is what? Opposite over hypotenuse, and then you square it, and then now the most you can lose is 1 point. So what do we got? 25 over 41 minus 16 over 41. That comes out to 9 over 41. Fox that, that's the answer. See, this really isn't that difficult, is it? Again, why am I asking you this? All right, now we gotta learn. What time is it? What time does the class end? 1:45, yeah? Well, if you finish early, maybe we can play a game. We'll see. Now, we are starting the book assignment, so if you look on your assignment sheet, it's gonna say 2.1, and then it just gives the numbers. Now, every year, I give less and less problems. So you guys are getting like, especially since we changed books, I'm giving less problems than ever before. You know why? Because the AP scores are always good, like at least 90% getting 5s. And then class of 2017, and then last year it went back up, and hopefully it'll stay there. So as long as we're doing what we're supposed to do, then the amount of homework here, this is time, and this is homework. Okay, so when I first started teaching calculus, just to be safe, you give plenty homework, yeah? But then after a while, no need, we're getting high scores, no need. And then 2017 happened, but I knew that was a fluke, so we just kept the same. So here you guys are. You guys got the least homework of anybody ever in AB calculus. This is like pre-calculus regular assignments. For Pete's sake. Anyway, so you got to look at the assignment sheet for the assignment. Everybody got the book, right? So,
yeah.
Okay, we are learning limits. Now, Mr. Cropsey assured me you guys are experts at this. Okay, let me give you a picture. Now, if you are given a picture of a function, then it's so easy to compute limit. Okay, let me just draw a piecewise function for you. 1, 2, 3, 4. Okay, here's 1. How about something like this? And then, how about this? And then, how about this? What am I doing? Oh, just draw. And then, how about this? No, you fool! How about this? Now, what the heck? Let's put a dot there. Here's a piecewise function. Okay, let me ask you some questions. Now, this is review now. So this next chapter, limits, is review, but I'm not sure how in-depth you guys went in limits last year. Okay, what is the limit of this function as x approaches 1, and what does that mean? From the left. Okay, here's 1, right here. Here's 1. Coming from the left, look at the graph. The graph is getting closer and closer and closer to this point right there, yeah? What is the y-coordinate of that point? 2. So that's how you figure out the limit from the left, or we call it the left-hand limit. What is the limit of this function as x approaches 1 from the right? Okay, now coming from the right, now look, the graph is getting closer and closer and closer to this point. What's the y-coordinate of that point? 4. So therefore, what is the limit of this function as x approaches 1. So if coming from the left, the graph is getting closer to 2, but coming from the right, the function is getting closer to 4, then what's the limit? What do I do? Take the average? Take the average, 3. No! What did Mr. Cropsey teach you? The limit? Mean Girls. Remember Mean Girls. The limit does not exist. You guys ever saw Mean Girls? Or is that movie too old? Yes or no? We saw it.
Yeah.
The plastics. Again, I'll just talk to myself already. So if the left-hand limit and the right-hand limit are different, the limit doesn't exist. You don't take the average. Okay? If they're different, the limit does not exist. And if you want to, you can write D and E. I'll let you do that. But I'll tell you what, on an AP exam, you cannot abbreviate unless you have a legend on your paper. But we'll worry about that in the fourth quarter when we study for the AP exam. Now let's look at this graph. What is the limit of this function as x approaches 3? Yeah, yikes. X approaches 3 from the left. Okay, so here's 3. Coming from the left, look, the graph is getting closer and closer to this point. What's the y-coordinate of that point? 3. What is the limit of this function as x approaches 3 from the right? Now, coming from the right side, the graph is getting closer and closer to that point. What's the y-coordinate of that point? 3. So, if the left-hand limit is 3 and the right-hand limit is 3, then what would be the limit of this function as x approaches 3, period? 3. So if the left-hand limit and the right-hand limit are the same, that's the limit. But if they're different, the limit doesn't exist. You guys should remember this, right? Now, what would happen? Yeah, but Mr. Park, there's a point down here. What did this point have to do with the limit? Absolutely nothing, that's right. Because we don't care what happens at x equals 3. We care what happens as x approaches 3. So that's the main thing. Okay, so if you have a graph in front of your face, it's really easy to figure out limits. I think I gave you 2 problems where you just look at the graph. Okay, but sometimes, in fact, almost all the time, we don't have the graph. So how do you compute limits? Now, this is another thing about the homework. The book has some funky directions, okay? Don't pay attention to the directions, okay? Just do the problem like I teach you. You know what I'm talking about? Because did anybody look at the book yet? Of course not. So, the directions are going to say, compute the limit analytically, confirm graphically. Or it's going to say, compute the limit by drawing a graph, and then confirm it algebraically, or things like that. Or work in groups of 3 or 4. Just get the limit. You know what I'm talking about? Just find the limit. Don't pay attention to the directions. I hope I remember to tell that in class. Okay, so let's start off with an easy one. Compute the limit as x approaches 2 of the cube root of -10 plus x. Now, how many of you know how to draw this graph? That's what I thought. So, yeah, sometimes we don't want to even draw a graph. So what do? What's the first thing you should do when you compute a limit? What did we learn last year? Mr. Sasaki said, you guys are good at this. You plug in the number. If you can plug in this number into the function and get something, that's the answer. So what happens when I plug in 2 for x? You get the cube root of -8. Really? -2! -2 is the answer. So if you can plug in the number and get something, that's it. You're done. Now, how many of these do you think you're going to get on the quiz or the test? Yeah, 1. You're going to get 1. But do you think I'm going to make it that easy? No way, Moose Breath. It's going to be something like this. What's the limit as x approaches pi over 12 of sine x? So plug in pi over 12. What do you get? Really? You can't plug in pi over 12 there? Sine of pi over 12. Now, if you wrote that on your paper, you don't get any credit. You gotta simplify that. Any ideas on how to do that? Okay, there you go. So sine of what plus what or what minus what will give you pi over 12? Pi over 3 minus pi over 4. Hey, and then you gotta use the identity. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. Anyway, you do all this work, you know what you're gonna get? Root 6 minus root 2 over 4. Please, Mr. Park, please don't do that. Well, how else am I gonna test your trig identity? Do you really think I'm gonna give you, okay, this is the kind you're gonna get, okay, the book, their problems are really easy. This is the kind you have in the book. What's the limit as x approaches 1 of 2x plus 1 squared? That's the kind they give you. Oh, let's see, if I plug in 1 there, you get 3 squared 9. Why would it give you that? You get crazy? Well, some of the ones tonight are gonna be like that. All right. Like I said, maybe on the quiz you might get 1, on the test, I don't know, maybe, yeah, probably 1. Okay, but let's look at some other cases. What's the limit? As x approaches, I'll give you something like the homework, 1. No, let's do 2, of x squared minus 4. No, I changed my mind. X cubed minus 8 all over x minus 2. Aha. Now, what happens when I plug in 2 in for x? What do you get?
0.
Very good. You get 0 over 0. And what did Mr. Sasaki call this last year? When you get a limit problem and it's 0 over 0, what is that called? Indeterminate. What? Did I spell that correctly? Is that 1M or 2M's? Who cares? Indeterminate. Indeterminate means we don't know what it is. We cannot determine what it is. So what was one technique you guys learned last year? When you have an indeterminate limit? It rhymes with simplify. You try to simplify. Is that the only way we can get it? So the first thing you should try, well, you gotta make sure, you always plug in the number first. If it comes out 0 over 0, you gotta do something. The first thing you should try is simplify. Like, can that be simplified? Yeah, you factor it. What happens if I factor the top? Difference of cubes. Remember I told you, you gotta know cubes in calculus. Difference of cubes. Somebody impress me. Lee. B. Braxton.
I don't remember.
Just take a guess then.
X
Okay,
minus
okay, wait, time out. Let's pretend we don't know. Let's just pretend. What could I do to help me remember this? It rhymes with synthetic division. Yeah, do synthetic division then, right? But come on, we should know. Okay, I'll do the first part. X minus 2 times x squared plus 2x plus, come on, the last one is
4.
obvious. Okay, 4. Because this times this got to be negative 8, right? I don't think like that, Mr. Park. The bottom is x minus 2. Hey, these cancel out. Now can I plug in 2 and get something? Yeah, what happens when I plug in 2? You get 4 plus 4 plus 4. 12, there you go, there's the limit. So, if you get oh, look at the time, we're in trouble, man. So, if you get a 0 over 0, the first thing you should try is plug in the number. I mean, what am I talking about? Simplify. This is plugging in the number. Okay, second case. I guess we're just going to have time to do one example of each. Give me a single digit number.
3.
3.